comma, live on every single platform. We are live on Facebook, YouTube, Twitch, Kick, as well as X. I am very, very excited to be back on Livestream this season 6. Our person design is taking multiple turns, and I'm joined with a great guest that I am looking forward to catching up on all the big and fun things that have been done so far since the last time we chatted. Welcome to Stimulator, Brandon. Come on, Brandon.
Hi. Yeah, thank you for having me. This is fun.
Yeah, well, for people who might not be familiar in the person design community, because most of us already know you, most of us in Rosetta Commons already know you, but those who may not be familiar, please introduce yourself so that people can know.
Yeah, so my name's Brandon Friends. I did my PhD in Frank DeMeo's lab at the University of Washington Institute for Protein Design. Me and Tamuka overlapped. I guess my claim to fame there was I was part of the team that solved the very first structure of a coronavirus spike protein, which we published in Nature. And so that was very exciting. This was a couple years before the pandemic. So it was a big deal at the time, but it was a big deal, or I could tell my parents afterwards, and they actually knew what I was talking about afterwards. So that was very exciting. Since then, I was one of the first employees at Cyrus Biotechnology, which was a company that spun out to basically make protein engineering easier to use, built a cloud computing platform to allow us to do it. Long story short, pivoted to another company. What?
And the first spin out from the Baker Lab, right? Cyrus Biotechnology.
Oh, well, actually, no, our Zeta, I think, was before us.
I see.
But it was pretty close. Yeah, there's been a lot of spin outs from the Baker Lab since then. But this was back in 2015 that we first spun out. So yeah, it was almost a little bit before its time, which was funny because at the time it seemed like, so prescient. But, with all the AI protein structure prediction and everything that came out a few years later, it's kind of crazy. Yeah. I like to tell people we have like 10 years of experience in a field that's only existed for 5 years because we blew up.
No. All right. So after Cyrus,
so after Cyrus, I was I kind of led the scientific team at Levitate Biotechnology, which was the company owned by Rosetta Commons. Unfortunately, that shut down last year, which is when I founded my own company called ProtoWorks Biotechnology. And I've been building essentially a cloud computing platform for doing protein engineering. So all of the latest and greatest protein engineering tools run securely on the cloud directly from your browser. So yeah, that's kind of what I'm here to tell you about, I guess.
This is exciting because you guys, I've already talked about Levitate Bio being my first sponsor for season 4 Stimulator Games, and that idea of having a dry bench, right, which is essentially a company that is focusing mostly on in silico tools and allowing those tools to be accessible to everybody in the world, regardless of whether they're in America or not, or regardless of resource constraints, is a great idea and is useful for us here at Simulator Games because a lot of our students are learning about protein design for the very first time, and so having access to these kind of tools is needed. And so, yeah, Levitate Bio, awesome. And now you have Proteus Studios. And the first time we actually talked about this, you were looking for beta testers. And I started looking into this, and so much has changed. This was before the adaptive competition, so this has been March of this year, I think, when we took a look. And you already built like a really great user interface. You already had tools loaded in there. You had bolts gen. You had AlphaFold, of course. You had a visual display interface. Brandon was very kind enough to give me credits so I can play around in there and give some feedback. We tried to make some designs for the RBX strategy, which was the adaptive competition. Which, by the way, I should update you on that. I don't know if you've paid attention to what has been going on, but so remember I made like 100 designs on the different ones, and then none of these were selected on the 300 designs that were selected from adaptive. Were any of yours selected?
I don't think so. No, I couldn't. I was trying to track them down. I couldn't find any.
Yeah. And then Protein Design for Africa, which is another group that is based in Nigeria. In fact, they are students at the University of Benin State in Nigeria. They actually also made some designs, submitted. None of those were chosen either. And so when we met up, it was like, let's see. And then, because Ginkgo had started the basically customer thing. You can just come over there and you can submit designs, and then they will actually just process them for you. So we ended up submitting our designs, or wanting to submit our designs to Ginkgo. We started talking about it quite a lot on Twitter and stuff. And Adaptive reached out and they're like, "Hey," because I already have designs with Adaptive, which is part of this simulator games project, and wrap proteins into proteins. And so they're like, "Hey, we will test 7 of your designs if you can pick them." And so I reached out to Protein Design for Africa, and then I picked 3 of theirs and 4 of mine. I ran them through bolts so that they all equalize with the same metrics, and then I just selected the top best of those 7. So I kind of had unique ones, one with RF diffusion, one with latent X, one, you know what I mean? And then they had ones that were designed with like N-terminal, C-terminal, and so forth. And one of them is a binder.
Oh, that's great. Nice.
Oh, yeah, they all expressed, but only one showed binding. And so we actually wrote this up on stimulator.com/PDFA. So there's a little write-up on there. I wonder if I can actually put that on here. Just also showing the graphs and stuff like that of it binding to PDFA, being Protein Design for Africa, it binding to RBX, which was really cool. And so now these students are students in Nigeria, they're undergrads. So they're actually going to present this at ABRACAMS, which is a conference for minoritized students. It's the largest conference there is, biomedical conference anyway, that is 5,000 students every year. And so they're going to present virtually. Stimulator is sponsoring them to do their little poster, their first poster ever. They're going to talk about this, which is so cool. And who knows, maybe we might even get a structure.
Yeah, dude, that's awesome. Congrats. That's really exciting.
Thank you. Yeah. But, so students, I want more students to have access to these tools. And so this is why I think your platform is extremely important right now. I've seen you've been making several strides since the last time we talked. So maybe catch us up on what are some of the new advances. I know, the protein design community is generally excited about ESM4 too and all this kind of stuff.
Oh, yeah. For sure. So, I guess there's been a few things. I kind of designed this whole platform because I do a lot of my own consulting work and contract work for protein engineering. And so I've been continuing to do a lot of that and sort of update with all the latest tools that have been coming out, because so much new stuff has been coming out since we last talked. You already mentioned ESM Fold 2, but that's probably the thing I've been the most excited about, is a combination of RF Diffusion 3, which has been out for a little while, but I sort of recently started using it more. RF Diffusion 3 plus ESM Fold 2 has just been a massive game changer for binder design and protein design in general. It's just so much faster, so much cheaper, because it's so computationally efficient. So I've been working on really streamlining that whole process as one of the things that have been in the platform. I don't know if you saw the tutorial I linked as well, because I have a very similar kind of mission where I want to focus on education and teaching people how to do this. So one of the things I added is a tutorial that kind of walks you through step by step exactly how to do protein binder design using RF Diffusion 3, soluble MPNN, and ESM Fold 2. And that's what I've been using on a lot of my current projects, and it's been way cheaper than anything else, and making it a lot more accessible. So I've been really, really happy with ESM Fold 2 in particular. The speed ups there have been really exciting.
Isn't it a weird world that we're in, that now Facebook makes drugs? ESM Fold 2 is from Meta, and they have been working on this for such a long time. And ESM1 is, and then the ESMC, and then which was part of a large package in May, I think was the drop. And so ESM Fold 2 now is, people are very excited about it, because not only is it super fast, but also can use MSA, but it's not reliant on MSA. And so there are many different advantages of it. Where in your pipeline within your platform are you fitting this in? Are you fitting it only for structure validation, or are you also focusing on inverse folding with ESM? Where are you putting this?
I have not focused on or done much of the inverse folding with ESM. I read the paper, and what they described didn't get me that excited. It seemed really inefficient compared to what I was already doing with RF diffusion and soluble MPNN. So I haven't focused on really trying to use the inverse folding or the protein design from ESM Fold 2. I might, I probably should get some more experience with it, but I was really excited to use the validation and use it as an oracle on my own designs, but I wasn't super impressed with what they described in the paper. I don't know. I have, like I said, very just kind of like tertiary reading of it. I haven't dug into it like super in detail yet. I don't know if you've tried it, and what your thoughts are.
I've not tried inverse folding either. I think my takeaway
Okay.
was very similar with you with ESM. I think also it's a hard bar to compete with protein MPNN. It's just a really hard bar to compete with that right now, and to move people away from that super easy, super fast tool that is almost always spot on. And really, where the bottleneck was, as you already said, was really in structure validation, right? How do we designs that come out of protein MPNN or even Boltzgen or whatever, how do we prune those down to ones that we have some confidence so that we can actually go into wet lab design? And so have you been doing some wet lab design to validate some of your stuff, or
Yeah, so I mean, I have some contracts with companies that where I do the design and they're tested. They have like their own testing going on. So we have some designs that are currently being tested, like designs I've made for a client, and now they're currently doing yeast display and doing all the wet lab work. Haven't got the results back yet. I've heard that they seem promising, but haven't found out. I have been doing some cool stuff too with ESM Fold too, because it supports non-protein atoms. So the project I've been working on in particular, one of them is heavily glycosylated. So there really hasn't been a lot of work showing binder design to glycosylated structures, but I built out a whole platform that's like really, really nice for just running glycosylation. And I don't know if you've ever tried to do glycosylation with like RF diffusion 3, but it's like a huge pain in the ass, or ESM Fold 2 as well. Like every single link in the sugar needs to be like a separate chain, and all the atom names have to match, and it's like this massive headache. So I've completely like streamlined that whole process and just like handled it behind the scenes. And I've got a really nice platform for working with non-canonicals, but specifically I've been focused on glycans recently. So that's probably one of the most exciting things.
I would be very interested in a quick tutorial. I don't know if there's something that you want to pull up.
Sure. I mean, I can show you the tutorial I put in for the binder design. If you want to.
I think you can screen. One of the things I'm very interested in your studio, ProteWorks. I keep wanting to say ProteoWorks. ProteWorks, right?
Yeah.
One of the things I'm very interested in this is incorporating it in season 7. We've been, briefly chatting about it in on LinkedIn and stuff. I would love to be able to get in and play with it, because I think, you have a similar model to like Tamarind Bio a little bit, right? In that, you're offering an interface that has all these available tools that are out there, but you're streamlining it down so that students don't have to have the headache of worrying about the backend code, worrying about, connecting two things with another or that kind of stuff. You're streamlining that all the way through. And so I think that'll be so useful for students at the universities that we are collaborating with. I'm collaborating with Hampton University in Virginia, but also folks at Claff University, my alma mater, would be interested in this. And just students have a hands-on perspective on this. And
yeah. Exactly. I mean, like you mentioned, there are a lot of tools, and new ones are coming out all the time, like even agentic versions and stuff. Where you can run all this stuff a lot easier now. And so it's definitely becoming more commodified. There's a lot of platforms like this, which is partly why my focus is on like, I want to give away as much stuff as I can for free. Like I really want to make it something, that's very much like educational and tutorials and all that kind of stuff. So a lot of the stuff, like all the tutorials you're going to see, you can access for free. Just go on the website. The molecular viewer, all that kind of stuff is totally free. It's mostly just the compute that you have to pay for, because obviously it costs money.
We love
that away for free.
We love free over here.
So that's a big thing I want to do. And then in terms of the advantages, like the way I kind of pitch it is like a protein engineering platform built by actual protein engineers for protein engineers. Because a lot of these tools just kind of give you like, okay, you can run everything and we'll spin it up on all the GPUs, but all of the kind of glue and the intermediate steps, like how do you analyze your data? How do you I want to impress on people like look at your structures in a molecular viewer, because a lot of people are doing like purely metric based design, and metrics are great, but like look at your structures and think about what you're doing as well. So trying to streamline that whole process.
Isn't that crazy? Like, I think it's really this advent of AI that people are just focusing on metrics and never actually opening the structure, because some of the things, even at Adaptive, when we were looking at some of the things that passed this 300 whatever cut off, and you just open the structures that were predicted either by bolts or whatnot. It was just like, this is garbage. Like, why would you choose this for wet lab validation? This is just like a long helix rod, which obviously is going to pass all of your metrics, but it would never ever fold in real life if you just take a look at the structure. Yeah, so I love that you have a structure viewer, which is so it's embedded within this platform, and so every design you're looking at, you can pull up the structure to actually take a look at it, right?
Yeah, absolutely. So like I mentioned, education's a big part of it. So we have these like binder design. Oops, sorry, what did I just click something? We have these tutorials that walk you through like step by step the whole process. So here we have binder design tutorial, and this is like designing a binder to PDL1. So it walks you through every single step, and you can kind of like see how to actually run this. So, you know, for your students and stuff, we can make a tutorial. We haven't talked about exactly what you want them doing in season 6, but we could definitely like create something like this that would walk you through like step by step how to do it, and then they can do it for real. But right now, so
students are coming in right now. That's a May scientist. She would be interested in this platform. She's actually a teacher in the University of, is this Pennsylvania, I think? And she's teaching some students there. So she would be interested in this in many different aspects. Okay. But yes, You're right. We have not talked about like the details and stuff, which, hey, no time like the present. I would love people to be able to pull up a wild type structure, some of their favorite proteins. Like, for instance, I have myoglobin up here. So it's oftentimes my go-to. But, you know, we also have, what do you have up here?
Yeah, so I just loaded this structure. This is a PDL1. So that's what we just did. We downloaded it from the PDB, and it's now sitting on like our file system in the cloud, on our like drive, if you will. And we've loaded it into the viewer. So this is PDL1. This is the like raw structure directly from the PDB. So it has 2 chains, it has a ligand in there, all that kind of stuff. So it'll walk you through the process of like, how do you clean it up and actually prepare it for the tools, right? So RF diffusion, you really want to like have a structure that's been renumbered from 1 to N so that all the numbering makes sense. And like, you want everything to be, you know, chain A. So starting in the middle, all that kind of stuff. So you can do all that right in the platform, right? So here we've gone and we've like cleaned up our structure, right? So got rid of all the ligands, all the non-protein atoms that we don't need, all that kind of stuff.
I love how it is to use. I love that. It's very similar to Pymol.
Yeah, that's actually one of the big things I wanted to do is like make it as familiar to people who know Pymol as possible, right? And it all runs directly in the browser, so you don't need to install anything. It works on any operating system, all that kind of stuff. My goal, I mean, I haven't used Pymol now in like, I don't know, a year, because I basically use this for everything. My goal is to completely replace Pymol, so you never need to do anything in Pymol, basically. Actually, my goal is whenever you do an entire protein design problem, you never need to leave the platform at all. You can do everything, all your data analysis, all your selection, all your preparing of the models, everything right in the platform.
One platform to rule them all. I love that.
I mean, I'm sure after doing a lot of protein design, you end up with like 1,000 different Python scripts to do all sorts of like crazy stuff and constantly manipulating your files and all that kind of stuff. So I really wanted to streamline that process.
I think that's a great idea, Brandon. Honestly, the biggest challenge I see in protein design is rarely ever actually designing the proteins. It's just managing the files, transferring from one to the other, going between data metrics to structure visualization and back again. Sequences.
And it's like, oh, you ran this tool and it used the charm atom names, and then you want to run an RF diffusion, but it crashes because it doesn't recognize those atom names. So you got to convert between. Lots of headaches. So
how are you managing that? Because how are you making things universal? Because you're right, these different tools all require different inputs. Like, for instance, Rosetta Fold is specific about what inputs it gets, target, and Fab, antigen, that kind of stuff, and protein NPN is different. So how are you solving that problem?
I mean, I have a bunch of stuff on the back end that handles it for you. Like, for example, if you have like atom names mismatch between like, I was using reglyco to add like charm glycosylizations to a structure, but then I wanted to use an RF diffusion and it like had an atom name mismatch. So like behind the scenes, when you run it, it will automatically like create a graph of your molecule and figure out what all the atom names are supposed to be and just like renumber it for you or relabel it for you and just feed it into RF diffusion. I'll show you in a second, like one of the tools, the way that works also. So here, this is just walking through the process of setting up your structure. We're going to select a hotspot. So it has all the same visualizations you'd expect from, like Pymol. So here, what I've just done is I've made a Pymol selection or selected some residues using like Primal selection syntax. As you can see, like, okay, here we've got this like hydrophobic patch on PDL1 that's been highlighted and shown in sticks here. So the idea of like of this tutorial is we're going to make a binder that that binds to PDL1 at that position. And then here's so one of the integrations I've added, which is really nice, is rather than have to like put in all the details to run like RF diffusion, you can just like right click and say, I want to add residues here. So I'm going to tell it like, I want to add a binder between 70 and 110 residues, or sorry, 100 residues on chain A.
Yeah.
And so we've added it up here. You can't really see it right there, but we've got like numbers indicating like, okay, we're adding new residues at this position. And then this is what I was kind of talking about, like the formatting. So RF Diffusion 3, when I run here, it's going to have me save the structure. And this will automatically like save it in the right format for RF diffusion. So for example, if you had like a ligand in there and every ligand needs to be on a different chain, it would know that and it would like format that input file properly for RF diffusion. So you don't need to know any of that, but it's all happening behind the scenes.
That is cool.
So so I'm going to save this model here. And the other thing is you saw I like selected all the residues that I wanted to make my binder to in the viewer. Right. So I can just import that directly from the viewer when I run RF diffusion. And so then it creates this page here that has like our submission with all of our different metrics and everything, or all the settings that we want to use for RF diffusion. And
can I ask you an aesthetic question? Like, are you able to change the background display? Like, you know how Pymol you can change this to white? As you're going, one thing I found is just like as I'm doing my design, I like to take pictures and stuff. You know, this is good it's good for posters and all this kind of stuff. Are you able to do the similar thing here?
Yeah. I can't show it without exiting the tutorial, but yeah, there are ways to do here. Let me just open up another window real quick. There are ways to do some of that. I don't have I can't remember if I have Backbone.
It could be food for thought. It doesn't have to be live right now.
Oh yeah, no worries. But certainly you can do things like take pictures. Actually, it's really nice because you can just like you just copy this and it'll copy it right to your clipboard, and then you can just go paste it in your slides as you go. So that's one thing that's pretty cool. I'm trying to remember if there's like options for controlling Backbone. There's definitely like various options in here. Like in this case, I'm just using a transparent Backbone. Oh yeah, here's back.
Make it white if you want it.
Yeah. So you can, there's settings. It's based on Molstar. So Molstar is the same molecular viewer that's used in the PDB. So all the features that are in Molstar, at least most of the features that are in Molstar are present here. And then I've added like a UI around it to do things like the Pymol selection commands. And like I have a molecular viewer, or a sequence viewer, which I think is a little better than the one that comes with default with Molstar and all that kind of stuff. But yeah, it's based on the same molecular viewer the PDB uses.
Nice. Can you run this on the phone?
You can't run it on the phone right now. Mostly because the rest of the UI kind of breaks.
Kind of breaks. Yeah. The phones don't have enough. Yeah.
Yeah. Okay. It's not so much the power. It's just like all of the sizing of everything goes crazy on phones.
Yeah. Okay. All right. So continue.
Someday maybe.
Sorry. Continue with the PDL.
Yeah. No worries. Yeah. So there you go. Back to the tutorial here. It's just got all our setups and kind of stuff, and it kind of like tells you like what settings to use. Here, we're just going to run like a test example on binder design. And so it like automatically sets up all your contigs, right? So I'm sure you probably know like RF Diffusion's input format is pretty annoying with like the contigs and all the different like, oh, you didn't put a space or a slash here or whatever, like breaks constantly. So I try and handle all that for you from just like a user interface, kind of like interacting directly with molecular viewer, import it all. But of course you can change it if you want. Yeah, and then here's some of the options, like the hotspot residues that we selected are already imported, all that kind of stuff. And then now we're going to run the workflow. So what this is going to do is it's going to kick off a job. Obviously this is being simulated, it's not real, but took about a half an hour to run that. And then up here we get our completed workflow. And you'll see some things here like, so it creates essentially, you have like a file system that is very similar to what you'd be using if you ran on like a supercomputer. So if you ran RF diffusion just on your own, you get all the files and they'll just show up right in your, like I said, kind of like drive, if you will, system over here. So this is going to take us over to our output folder. which has all our PDBs and everything in it. And then I've also have this system where we create these .studio files that are going to have a ton of different metrics and plots and all sorts of things that you can interact with to kind of analyze your data. So here we have like a plot of radius of gyration. Obviously, this is one of the main metrics you want to filter your RF diffusion backbones by to make sure they're not like long helices and nothing but long helices. So you can analyze all that kind of stuff. But then you can also do things like over here, we can plot like the fraction of beta sheets, right? So we want to make sure that we are actually getting diversity in our models. So this structure, we have quite a few non-all helices, right? We've got lots of beta sheet structures in here. Same thing over here. If we look at the helix fraction, you can say, okay, yeah, we've got like a pretty reasonable, distribution of helical and non-helical secondary structure elements in our structures, which is what we want to see. And then when we want to load into the viewer, we can just click this button right here, and this is going to load all the structures. So just have to give it a second.
This is really cool, Brandon. Oh my gosh.
Yeah.
Like the fact that you're linking like the metrics and graphs and stuff with your structures all in one place, like that is so ideal. I'm seeing people asking questions here. We have a student, Ben. Ben, I don't know if your mic is on. Do you want to ask your question? Ben is actually in Zimbabwe, so maybe the internet might be spotty right now. Jump in with your question when you have it, Ben. I saw you going in and out, so I wanted to give you the opportunity. But yeah, go ahead, Brandon.
Yeah, sure. So now we've got all of our backbones loaded into the molecular viewer, and excuse me, you can just use like the arrow keys to cycle between them. And just kind of like check them out and say like, okay, am I getting stuff that's, they're fairly protein-like? Does it look reasonable? All that kind of stuff. We can see like, okay, yeah, this is pretty good, right? So this was just 20 backbones. And this is kind of this is my typical process when I'm like making a binder to a new target. I'm like, okay, let me set up all the settings. Let me run a small test job and make sure that the things I'm getting out look reasonable, right, before I go into full production. So that's the idea here. And then when we're ready to go into full production, we can go back to the workflow and we can just rerun it, and it'll just give us all the settings we used on the original design, and then we can just scale it up to a full production run. So usually I generate like maybe 2,000 backbones for a protein design, and then we just run the workflow. And again, it's going to go check out a bunch of GPUs and run everything on the cloud. And then we go over to here to the workflow status, and we can see like all the things that ran. RF Diffusion 3 has like a lot of settings for it, which can make it really tricky to set up for new users, because you can run multiple jobs on the same GPU at the same time. Like it can run in parallel, but it is limited by how much VRAM you have on your GPU. And that's going to be different for every single design process. So what this does actually is ahead of time, it will run kind of like test jobs of your first set of designs. And it will look at like how much memory is it using? How long do the jobs take to run and all that kind of stuff. And then from there, it figures out like the optimal way to parallelize all your jobs across lots of GPUs. And so then it'll run, like hundreds of GPUs or dozens of GPUs, depending on what it figures out is the most optimal way to parallelize everything. And it runs everything on the cloud, like in massively parallel jobs. And the nice thing about that is because we do all this optimization to like make it really efficient, you can generate lots of designs for fairly cheap. So I generated like 2,000 backbones for about $30 worth of compute, which I don't know, I don't know how much experience you have with like running RF diffusion or all these kind of other things on the cloud, but that's
on the cheap end. Yeah,
that's very cheap. Yeah. Like this pipeline, I get
that's a collab subscription per month. A collab phone subscription per month. Right? Yeah. Wow.
Yeah. Before I started using this whole pipeline, when I was using like BoltzGen or Minecraft or so, I could spend like $1,200 on a reasonable set of designs, and now I get like tons of designs for maybe 100, and it's coming down all the time as people come out with new methods. But yeah. Anyway, moral story is RF Diffusion 3. Don't use RF Diffusion. Don't use the original one anymore. The original one is dead. RF Diffusion 3 is super great. Better models, really fast. Love it. But yeah, you have to do all that setup, which gets handled for you on the platform.
But do you like the sequence that RF Diffusion 3 comes out with, right? Because the old RF Diffusion 3, we had no sequence. It was just a polyglycine backbone that comes out. Now it comes out with some sort of a sequence, which compared to like protein MPNN is...
Do not use those sequences. Those sequences are garbo. Yeah. Well, the next step we're gonna run protein MPN and you'll see. But no, those sequences are garbage. Do not use the raw sequences coming out of RF diffusion. I mean, just look at them and you'll see like 10 alanines in a row, and you'll be like, okay, yeah, no, that's not good.
But I like that it has some sort of sequence already, because when you then do protein MPN, you're almost doing like a cycle one, which every iteration
sure.
of protein MPN, you're almost getting like a diverse set of sequences that come out, right?
Yeah, I think in the paper they did say that the sequence presence helps, and it seems like it does. Like the backbones are really good, but yeah, I like the first time I'm like, oh, I'm gonna try these sequences in my designs, and like none of them folded back up into the design. It was terrible.
Ben typed his question in the chat. He says, "How easy is it?" What is it? Sorry, the chat went off. How easy is it
for
to
non-tech savvy students here in Africa, Zimbabwe to be specific? It should. I'm trying to make it as easy as possible. So I try and make it smart about making sure you could just like interact with it in a very unified way. One of the things I want to do is there's a million different tools, right? There's RF diffusion, there's BoltzGen, there's Bindcraft, there's Proteina Complexa, there's so on and so forth. There's so many. So I'm trying to make a system where you can kind of use the same UI for all of them, and then it automatically figures out what the right way to configure it is. So we kind of saw in the beginning of the workflow where it was like you right click and you say add 50 residues, and then run RF diffusion or Proteina Complexa or BoltzGen. And then it just sets up all the inputs to be exactly what you would need for that specific tool. But you get to interact with it the same way every single time. So that's what we're going for. And hopefully that makes it a lot more straightforward, so you don't have to know for each tool how to do it. One of the tools I'm working on right now too is like a tool for running like all the different structure prediction methods at the same time with the same interface. So you want to run, AlphaFold 3, or not even AlphaFold 3, but like Proteinix or OpenFold or Rosetta Fold. It's like you just say, here's my sequence, here's the ligands I want to include, here's the go, and it will just automatically create all the input files for every single one and run it all.
I like that so much, because have you seen a lot of correlation between protein folding models? And like this is something some people look into, but it's super hard to do when you're doing one after the other, and it's a different interface. So this would be a nice way to do it.
Hold on, my computer crashed right before. Do I have my jobs up? Let me let's see if this will run, or this is open. This is like my local environment because I haven't pushed this to the cloud yet. Oh wait, you can't see this because I'm only sharing that window. Oh, sorry.
You're doing a very safe thing, sharing only one window.
I wanted to be very careful.
Because we are live, yes. But also, we have very few people watching. We can always trim and cut it out.
No, that's fine. All right, well, should we... Let me see if I can pull this up real quick, and then I'll share that screen.
Is this because something's running right now, right?
Nothing's running right now. We're just running the tutorial, but I just wanted to show you something I've been working on, which isn't in the live version yet. It's like just what I've been developing on my local machine.
Ooh, we get spoilers, y'all. We get spoilers.
Let me find it real quick.
And by the way, when I first talked to Brandon, there was no logo. Okay, now there's a logo. This looks good.
I know. I got a hat, custom made.
Some merch. Okay, so what is the logo of? Is this for Dachshund? What is that?
No, it's just I just took a helix and a beta sheet and like overlaid them in each other. It's not from a particular structure. Well, it is, but I don't remember what it was. I just like overlaid them to like kind of make like that. If you've seen like the wrench and screwdriver kind of like construction icon, I was like trying to be inspired by that. And so I took a picture and then I like cartoonified it, and then I had an artist like go and actually like turn it into something that looked more like a professional logo.
Nice. I love it. Okay.
It is technically based on a real secondary structure elements.
So you guys, you see, AI people are still commissioning traditional artists. See, look at that.
I did.
There's a room for collaboration. All of this,
okay, I'm gonna stop sharing and I'm gonna share a new screen real quick so I can show you this, because since we were just talking about it. All right, we'll be brave. I'll share my whole window.
That is very brave indeed.
Okay, here we go. Oh, are you seeing it?
No, not yet. Oh, I think you have to do the present thing, or do I have to do it on my? Oh yeah, I think I have to do it on my end. Yeah, here we go.
Oh, there you go. Okay, yeah. So this is exactly what you were talking about, where you're like, what's the correlation between all the different methods? So here I've run this structure. Well, let me load a copy of it into the viewer. It's this guy here. I can't remember what it was. It's like IL-12 bound to a specific target. But that's what the structure looks like. But yeah, so I basically have this UI here where you can run all of the different structure prediction tools. Let's see, where is the one I ran all this?
This is so cool. And you run them at the same time?
Yeah, you run them all at the same time.
So they're running in parallel, as you were saying, like on different GPUs or even on the same GPU, just multiple nodes or whatever, multiple jobs.
Yeah. Interesting. All right, well, here, I'll just show. I'm trying to find, like, you can see a bunch of them failed because I was developing it. Oh, here's the one. Yeah. So yeah, so you can just like click load from file and load from a FASTA file or a structure or whatever. Or just like load your sequence, or you can add, your ligands and your DNA and everything else. And then you just get to select like between all these different structure prediction methods, whichever ones you want. And all you have to do is just like check the box and then run it, right? And it runs all of them. And then it makes those similar .studio files like this, which is what we have here. So here we have like all of our predictions, and what we have up in this plot right here is PLDDT for every residue for each one of the different methods, right? If I can like select them, you can see like ESM fold, for example, is that one in brown, right? ESM folds the previous, before ESM fold 2, this is the old one. It was like really fast, but it didn't use MSAs and it's like much less accurate. So you can see that it like did a much worse job than all the other structure prediction methods. But you also asked about like correlation. So over here we have like they correlate very strongly. We can load them all into the viewer at the same time, and you can see.
This is cool. This is really cool.
Oh, and they're all being colored by the PLDDT.
That is cool.
Yeah.
And you didn't pre-prepare this, did you?
No. I mean, no. Like this. I mean, this is a job I ran yesterday or whatever.
No, I know the job is already ran, but even as you're going right now, like this is not a video. Like you are literally
no. This is live.
The outputs, so the speed is on par. Like that's what I'm appreciating here is the speed. There's not much lag. You're literally able to apply all of your coloring, all of your different, analysis as you go through. Ben keeps coming in and out. Ben, you don't have to sacrifice your network. I know it's a challenge right now. So thank you so much. I appreciate the comments in the chat. You don't have to keep coming in and out. But okay. This is so cool. So what you're overlaying is the same structure, but just predicted from different models.
Yeah, so we have the model. So each prediction method, sometimes they produce more than one model, right? So OpenFold 3 has like 3 different copies of the 3 different models in OpenFold. We've got like 5 different models from Kai1 in here. And then like you can notice just looking at this, like one of these is not like the others, right? Like clearly there's one that's like very different. Yeah. And that's the original ESM fold, where is it? ESM fold down here, right? So you can see like all the other methods are very well converged on most of the structure. Obviously this hue, like the termini over here is a mess, right? And the PLDDT indicates that. Yeah. And if we look at the plot down here, this is the RMSF, which is essentially, it's like, you can think of this as like the deviation at every position between the models, right? Yeah. So where it's low, it means like all the models agree very strongly that this, like they all basically have the same structure over here. Whereas like a region like this is residue 101. Like the models do not agree. They're very diverse, right? Whoops. Let me make sure we have the right chain. But yeah, you can see it's like this loopy region, right? Which is what you'd expect, right? The loop, all the models are kind of different in the loop. So yeah, as you can see that like right in the 2D plots and then in the 3D plots and all that kind of stuff.
That is so cool. Because can you imagine, you're running one that's based on MSA, one that's not based on MSA, one, diffusion based, different ones, and kind of get an orthogonal validation from different methods all in one. So when
Yeah.
is this coming through into the?
So I'm hoping to get this out in the next few days, and then I'm going to make a tutorial. I think I mentioned to you I'm working on a YouTube channel, so I'm doing a
Yeah.
whole series on protein structure prediction, teaching people how to actually do protein structure prediction. So there's 2 videos that are done that I'm hopefully releasing soon, and then I'm trying to get this out, and I'm going to make like a tutorial that walks you through like how to do it and talk about like what the metrics are and how to interpret all your protein structure prediction results.
Cool,
Yeah.
cool.
So
cool.
hopefully soon it'll be
What's
out.
your YouTube channel name? I'm gonna put it on.
It's protein engineering. There's nothing on there yet, so there's not much to look at. But
channel protein engineering. Congratulations!
I know. I was like, sweet, this isn't taken. I claimed it like a year ago because I'm like, someday I'm gonna make a YouTube channel on this.
It's literally just protein engineering.
Yeah.
Wow. So it's like youtube.com/protein engineering.
Let me make sure that sometimes YouTube gives you funny links, but
yeah, sometimes it wants you to put like a C or whatever, something else. But yeah, but basically,
let me.
And then somebody in the chat has been asking. Amazed Scientist says, "Can you show the name of the program?" I think we've been showing that a couple times. Mahalia, here we go. Let's put that on the screen so you can copy it. Studio.proteworks.com. And then she says, so awesome. Can you, thank you for sharing and including us. Jump on in. We're gonna use this for season 7. Honestly, we're definitely gonna use this for season 7. I think the students would be so excited about this. I just have to get Brandon to give us a lot of credits.
Yeah, I'm happy to help figure that out. I mean, one of the things I need to do is get like a bunch of people to use it all at the same time and see what crashes. So,
Actually, what I'm going to do is, here we go. What I'm going to do is actually give them a challenge. So it's not going to be the same thing as we were doing, with previous seasons where it's like rap lyrics, that kind of stuff. We're actually going to give them a challenge of a binder design problem that is in agriculture or in textiles, that kind of stuff. And then, it's going to be a time clock to basically who designs that first, and so using definitely this app, people would be able to learn the full gamut of things, but also probably be able to do it much faster. So
yeah, sure. Cool. So, yeah. We'll have to have some discussions about how to set all that up, but I'm excited. Yeah. Oh, so that's your YouTube channel. I just put it in the chat. Yeah,
that's crazy that you.
Like I said, nothing on there yet, but it's coming.
That's insane. How did they let you get that? That is insane. That's awesome. That's so cool. I'm subscribed. Here we go. We'll be looking forward to episodes or video clips for protein engineering. Use ProteaWorks. And there'll be clips from this section that's going to go on Stimulator, youtube.com/Stimulator. We're going to tag you over there in protein engineering so that people can easily find this. And thank you so much, Brandon. What would be the most useful thing for protein designers who are coming across this right now? What would be the most useful thing for them in terms of playing around with the tools here? Yeah.
Oh, yeah. So, I mean, you can go through this binder design tutorial that I'm working on, or that you're seeing on screen right now. Actually, I guess there you go. If you want to play around with that, that's cool. If anyone's interested in testing it, let me know. I'll give you some credits and like a month subscription or whatever. And then, like I said, like the molecular viewer and a bunch of the other stuff you can just use for free. It's only the compute that has a cost associated with it.
Cool. Yeah. Are you participating in any competitions coming up? Because hey, that's another way.
Are there any competitions? What competitions are coming up?
I've been keeping my eye on Adaptive. I've been refreshing. It looks like they are gearing up for another round. It looks like right now, but there's also like Innovate, Aligned to Innovate. They also have been doing some competitions, I think.
Okay.
And so yeah. And then I don't know if Rosetta Commons is ever doing competitions. That seems like something they should definitely do, like hackathons for design competitions. That would be cool. Did you go to RosettaCon?
I did not go to RosettaCon this year. I was bummed, but I think you knew I had a baby earlier this year, and my wife went back to work, and she doesn't start daycare for a couple more weeks. So I was like, I can't really just head off.
Next year, you can take
next
the baby.
year I will definitely be there, 100%.
You can take the baby with you next year. A year old, right?
Oh yeah. We'll make a trip of it. It's in Seattle now at UW, which I know people are bummed because it's not like out in the forest, but it's a lot easier to get to.
Yeah, no, that's true. That's true. I was able to tune in virtually. Hopefully next year will be in person. We'll see.
Nice. Well, we'll have to meet up.
For sure. Oh yeah. All right, Brendan. Well, thank you so much for coming on. Of course, we're going to talk some more in the future. And you guys, Brandon is not going to be a stranger here at Stimulator. So make sure to keep an eye on this space. Thank you so much for coming through. Oh, it looks like people are already excited. Looking forward to playing with the platform. Yay, more classes. Yeah, looking forward to this, Brandon. Talk soon. Thanks again. I won't see you later. I will steam you later.
See you later.
Bye, Brandon. All right, you guys, this has been my birthday live stream, okay? We did 2 live streams, essentially. One where we had Aaliyah, and Brandon, I'm going to let you go if you want to dip out. Feel free. But right now you're in the backstage, but feel free to dip out if you want to, or stay, whichever way. We have Ritendo a little bit later coming on here to show us what she's been working on throughout her internship in North Carolina. So hopefully we'll have her coming in very soon. I also had a student in Ghana, I think, who wanted to do a meet and greet. So we'll have her come through. But today has been an exciting day, you guys. It's my birthday. Happy pink birthday to me. We met up with Aaliyah. Aaliyah was on here. We got to see all the Steam Slop videos and get her take and her perspective on these videos that we are posting that are basically personifying these amino acids that we are talking about as part of this season 6. What's exciting is we've had students throughout win prizes for identifying the specific lyrics, but also identifying the amino acids that are corresponding to these Steam Slop videos that we have. Shout out to Amazing Scientist who won several times. We have Ben who was also able to win. We have Truman who was able to win as well. And several others. And we're only 8 days in, you guys. We have several more videos coming up. In fact, today I'm actually going to post the next Steam Slop video right now live. So in order to do that, I'm going to play my little song, and while my song plays, you guys, I'll post it on Instagram. So you guys are familiar with this song. This is Mwana's Team, My AI song. Shout out. And the EP is coming, you guys. It's coming, okay? But here's Mwana's Team with Science Rules the World, okay?
Lab coat dripping Einstein swag. Pocket full of data, quantum in my bag. Microscope vision, see the unseen. Atoms doing salsa in the laser beams. But an atom made the universe blush. Big Bang Theory, now we're in a rush. From the Petri dish to the Mars terrain. Science got the juice running through the veins. Science rules the world, we the new kings. Gravity bends when a genius sings. DNA spiral, stars align. This is our time, yeah, our time to shine. Science rules the world, we the new kings. Gravity bends when a genius sings. DNA spiral, stars align. This is our time, yeah, our time to shine. Sun cooking up in that particle stew. Higgs busting by breakthroughs on cue. Black holes whisper galaxies collide. We surf the cosmos, call it science pride. Neurons sparking like a Tesla whip. Brainwaves dance and take a data trip. Climate change and we reverse the heat. Algorithm marching to a future beat. AI scribbling symphonies of math. Genius blissing past to the aftermath. Telescope eyes on the most ring. We the architects of the future sing. We the architects of the future sing.
That is Mwana's Theme. You guys, I'm very excited about this song. It's been out since November, but I'm also very excited about the EP coming out. All right, I'm posting the next Team Slop video, so you have, if your notifications are on, you will know when it drops. And so you got to be the first one to answer the question. And of course, we are on episode 6 now, which Aaliyah already predicted her choice. We'll see if it's correct. And it's going live now on Instagram. I need to make sure that I have a good caption. So I'm also going to play our theme song for this season. Our theme song comes from K Chaps as well as Dreamo. K Chaps is a Zimbabwean artist, and Dreamo is from Zambia. And I'm playing their songs because actually I'm allowed to play their music. Some of the strikes I'm getting on YouTube are really because of the Nicki Minaj songs that we're playing. All of these Nicki Minaj songs that we're playing is the reason why I'm getting those strikes. But I think catch-up songs, I think I can play. Nobody is really giving that. But yeah, we're playing Remedy by K Chaps and Dreamo. And while this plays, I'm posting on Instagram.
Say now. Can I be your lover? Can I be the one? Oh no, that when you're feeling low, I'll be your shoulder. Can I jari masaje maoka? Oh God, I'll be your lover. Swear I'll treat you right, baby, someone. And tell me where you wanna go to, man. You've been through a lot to notice it, finally. So can I be your remedy? Can I be your remedy? Say I'll be your remedy. Oh, such fancy way, God. Can I be your remedy? Can I be your remedy? I'll be your remedy. I know you've been hurt before, so I don't intend doing so. Yeah, I really wanna make you happy, you know, but I never wanna rush you no more. Pretty lady, you're magical. Can you let me in now? Chica composite, every little second that you wasted there, yeah. They can call it, then you hear me. Composite, can you let me love you in my way? Can I be your remedy? Can I be your remedy? Say I'll be your remedy. No, such fancy way, kind. Can I be your remedy? Can I be your remedy? Say I'll be your remedy. Such fancy way, kind. Can I be your remedy? Woo!
That is our theme song for this season, Stimulator Games, aka the Steam Slop season. Shout out to the folks who are coming in. I gotta head out. Have a good live stream. Thanks for having me. Biohack TV. Hello. Oh, that's Brandon on Twitch. Okay. Shout out. All right. Okay. Activate that Twitch. Okay. Thank you for tuning in. We appreciate you also being a guest on here. Thank you. And then do we answer here or on Instagram? Mahalia asks. I think if you come on here, if you click the link, and because if you typed here, you must have come into the backstage. Yeah, come into the backstage and answer live. Turn your mic on and answer live. That'll get you some bonus questions, okay? But yeah, the episode is officially live. I am quickly going to show it. What is that? What was that? I'm quickly going to show it real quick because I'm also excited. I'll be watching it with you for the first time in a while right here. Let's go. I made these a while ago, you guys. It's been a while. Pink Friday 2 came out at the end of 2023, and I wore it out most of 2024. And then this idea came about when Sora was a thing, and because you can see all these videos are made by Sora actually, and so actually not all of them. There's a transition later on that's coming up very soon. We're gonna transition to a different thing, but spoiler alert. And so it's been a while. These have been out, and so I'm very excited about them. So all right, let's take a listen to now the next episode, which is episode 6. I just know we're going to get banned for using this, but let's go.
You might need to calm down.
City Dreamville, y'all feeling good tonight?
All right, you ready for the next contender?
It's family first through the worst, coming second to none. Real.
Glad to have you, brother.
Let's do it. Ladies and gentlemen, make some noise for R&B.
Appreciate it, man. Glad to have you, R&B.
Let's do it.
All right, that is episode 6. So some of you were right, actually. I think for the lyrics that are coming up, some of you are correct. Let's see. People who were guessing the lyrics in the comments. Let's go to the comments. Somebody wrote, I wrote a line for you. Aaliyah was not correct. She was correct in the song, it being Let Me Calm Down. And she picked a lyric from that song, but not the right lyric. But somebody did. I remember somebody pull off, and I almost hit him. He acting like I ain't always with him, while I'm screaming out, I hate him. Ain't no more debating. This time it's an ultimatum. That is a line from Let Me Calm Down. It is not the line we chose. But shout out to Ben. You get points for that. Just like Aaliyah got 30 points for her line, you also get points for that line. But somebody got the line correct. Oh yeah, here we go. Ben did get the line correct, just in a different. Okay, Ben, shooting shots, several comments, and not just one. I wonder if I can pin this comment, because yeah, that's the line, that's the lyric. I wrote a line for you, and it was beautiful. I made a song for you to say you're beautiful. You're so irresistible. Take me somewhere mystical. I don't know about that last part. I don't know if that's correct. Oh, who said that? Nikki said that? Are y'all copying from Genius? Where are y'all copying from? Because you got to make sure you get Nikki's lyrics correct. But yes, Ben, that is correct. Ding, 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 ding. Ben wins this episode. He definitely predicted the exact lyrics. Now, we have some bonus questions on this episode and the last. Make sure to answer those questions. For instance, in the last question, it was, what is the color? Truman got that color correct. It was gold. And then Ben also got the bonus question correct when we asked about why is cysteine in particular, why is that a special amino acid? And yes, it has a role in stabilizing protein shape, which is basically his comment. Shout out to Ben. Thank y'all for playing. Appreciate you. Here you go, Mahalia. Hey, I see you. Shout out to you. Did you see the episode?
Yes.
Hello. Yeah, what do you think of it?
I loved it.
What do you think of the season so far? Yeah.
It is exciting to go back and forth and like listen to the songs and then find a favorite lyric, and everybody has an opinion about what's the best album from her.
Right. Everybody has an opinion. What's the best lyric too that I'm gonna choose? And y'all are picking the wrong ones sometimes, but sometimes you're picking the right ones. Congratulations, you were able to win on some of them. We donated to your charity, but also we're gonna give you some cash prizes as well. Tell us a little bit about the Donor Choose charity for how you
Okay,
basically things for your
so
students.
teachers are allowed to do donors choose so that they can get materials for their classroom that they wouldn't normally get out of school. So I have some things on there because this year I'm teaching a new curriculum. So it will allow me to be able to purchase items that I might want to use to help the students learn science in a different way, more like phenomenon based learning. Because that's the direction that it's going, but it's a little dry. So I want to do some creative stuff too to get them kind of excited about science. So I want to do some more, like, I would say, experiments and things like that. Give out prizes to, like, kind of like what you're doing when you give us prizes for answering questions, right? I want to do that actively in class so they can stay engaged and be encouraged to learn science.
I love that, Mahalia. That is so awesome. And what school are you at? Tell us a little bit about what you're teaching and what
So
age you're
I'm in
starting.
Harrisburg, Pennsylvania, and I teach at Central Dauphin East High School. And I am teaching this year STEM and biology, which I've been teaching. In my STEM class, I'm able to do stuff with protein design. Like I had a young man that was interested in learning about proteins last year, and he was able to use your platform to look at protein.
Oh,
So
that's so
that
cool.
was really cool. Yeah, like I mean, he looked at, he said he was interested, so I let him play around with the program itself. So I'm looking for a program that's, I guess, student friendly, where they're
Yeah.
able to use it on their Chromebooks, because that's the biggest issue is that they have Chromebooks, and so a lot of programs and things don't work on there. So I have to try to find something more user friendly for them to be able to download and use.
Well, definitely the program we were just showing with Brandon right now, just before you came on. It seems like that works on just the website. Like you don't need to download an app or anything. You can just work that on the website. So that would work on the Chromebook. Did you get the name? I know you were asking about the name. Did you get it? The
Yeah, I
name?
screenshotted it.
Okay, perfect. Yeah. And I'll just put it on the screen again for those who might not be coming in later on. Yeah, this is studio.proteaworks. And so if you go to there.com, you'll be able to use it. And so, yeah, Mahalia, this is awesome. You have played simulated games every season since season 2, right? Like you have participated
Yes,
in this. This is awesome. I appreciate you
it's
always coming.
exciting.
Yeah, okay, good. And you're winning. Like you literally won cash prizes, of course, for participating here, and that's gonna come through to you. Let us know how to get it to you. But also you won your donation. So we donated to your classroom, and so those,
Yes.
let them know the stimulator said hi, get you some cash prizes. And if you want, you can also show them our website where we show a protein every single day. It's stimulator.com/proteins. They can go check this out. So the proteins that I highlight in my molecular minutes every day are usually from this website here. So today we're looking at lambda repressor protein, and you can see the protein in complex with DNA. Your students can actually go in and manipulate the protein. You see, they can play around with the protein every day, new protein, and so it's an easy thing for them to just go in there and jump in. So make sure to take a look at some of these different offerings we have.
Yes. Thank you.
All right, thank you so much, Mahalia. Now, do you have a prediction for the next episode? Because we just watched Let Me Calm Down. What do you think the next song is going to be?
Is it R&B?
It is R&B, yes. And so you saw in there we introduced R&B. Okay, so on the spot, tell us what is your prediction for the next song. Don't be going to Genius. I don't want to see your phone go to black. Okay, well, let's stay right here and give us a line.
Oh, for R&B?
Yes. What is
Oh
your
my
prediction?
God.
I love putting people on the spot. Yes.
I don't know the words. I gotta think. It's been a long time since I listened to that song.
Yeah. Okay, well, you got time to put it in the comments before the next episode comes out tomorrow. I'm very excited about this episode. We've already introduced the character of RB, who y'all might already recognize. Maybe he's inspired by a very familiar face. Hey, shout out to Tate Cobain. Obviously, the character doesn't look anything like Tate, but I think the personification of, I think his energy and aura, anyway, might be in my AI character. So shout out to Tate. Hope you don't take any offense with this or the next episode. If you ever see it, I'm still your sister. All right. Otherwise, I think this is about to be it. We have one person who's supposed to come on here, Ritendo. I don't know if she is coming now. Oh, I think we said 8:30, so I guess we'll wait for her for a little bit. But Mahalia, thank you so much for coming up. Okay, I appreciate you, and thank you for coming to take your time on here. Appreciate you for watching and playing Stimulator games. I'm gonna play a song while I take a little bit of a break, and then we'll be right back at 8:30 for Ritendo to come in, and we have a little chat. Let's go. Okay, let's play. I don't know. I'm gonna play a different song this time. Well, at first I gotta play my song. I gotta play my song because I gotta get these streams up. Okay, I gotta get the streams up. I wish we were doing Station It.
These spiral stars align. Lab coat dripping Einstein swag. Pocket full of data, quantum in my bag. Microscope vision, see the unseen. Atoms doing salsa in the laser beams. But an atom made the universe blush. Big Bang Theory, now we're in a rush. From the Petri dish to the Mars terrain. Science got the juice running through the veins. Science rules the world, we the new kings. Gravity bends when a genius sings. DNA spiral, stars align. This is our time, yeah, our time to shine. Science rules the world, we the new kings. Gravity bends when a genius sings. DNA spiral, stars align. This is our time, yeah, our time to shine. Sir cooking up in a particle stew. Higgs busting by breakthroughs on cue. Black holes whisper galaxies collide. We surf the cosmos, call it science pride. Neurons sparking like a Tesla whip. Brainwaves dancing, take a data trip. Climate change and we reverse the heat. Algorithm marching to a future beat. AI scribbling symphonies of math. Venus listen past to the aftermath.
We might go into VR real quick while we wait for Nintendo to show.
We the architects of the future sing.
I love that song. I made that song in AI and I love it. Shout out to Wanna Steam. Shout out. All right, folks who are still watching, thank you so much for tuning in and watching either live or on the replay. We're going to wrap up soon. We just have one student who's coming through, Ritendo, a Zimbabwean student who is doing research and her schooling here in America. And we have kept up with Ritendo's journey ever since she arrived and how she's been going from freshman. Well, she went from a community college student to a freshman in a 4-year college degree program, and she's done internships in different places. She's even presented at conferences. She participated in Stimulator Games season 2, I believe. Yeah, and I think even got into the top 10. So shout out to her. We want to catch up with her, find out what she's been up to, and of course, how Stimulator can continue moving her journey forward. So we'll give it a minute or two to see if she'll click the link and join, and then we can have that chat. Let's see. She might even be online watching right now. Oh, did I say red? Okay. So let's give her a minute. Maybe she's setting up her computer. And we'll hear the little boop for when somebody comes backstage right here. I'll be able to see them right here. Okay. I might go into VR real quick and play around with Nanum while we wait, because I do want to connect what we did today to Nanum. Oh. Okay. And I can hear when she comes in, it'll make a sound. Oh, there we go. Oh, no, that's Mahalia. Hey, Mahalia. You're back. Shout out to you. Okay, I'm going to wait for Rutendo, and I'm going to be in VR real quick. I want to see if we can pull up some of these proteins we were talking about today, whether it is some of the ones from grad school, or myoglobin, which is this protein right here, or even some of the agricultural proteins we've been discussing in the design context. Okay, let's see. Once it's up on here, I think I can share the screen. Stop sharing this, and then put that away, put that away, put that away, put that away. Oh, people in the Instagram it's popping in the Instagram. Oh, I see Rutendo. Hey, Rutendo, how's it going?
Hi, how are you?
I'm doing well. I was about to jump into VR while waiting for you. I was about
Oh yeah,
to...
I just saw your text and I'm like, oh my goodness, let me try to log in.
Okay. No, perfect. I know you're very
Are
busy
we
sometimes.
matching? Are we matching?
Oh my God, we are! Look at that! Look at that! Is it a coincidence, or you've been watching the stream?
No, it's a coincidence.
Yes. Well, I was just talking about you just now with the audience about how proud I am of all of your accomplishments so far. Honestly, you remind me of a young version of Tamuka coming into this country, navigating the struggles of international student, but then quickly finding your footing as a STEM student as well. You know, you've been doing really amazing stuff, Rutendo. We're so proud of you,
Thank you
going
so
from
much.
research institution to research institution, presenting at conferences. I can't believe you were right here at Harvard PubMed when I was in Canton, and we missed each other because we still haven't met in real life, which is
I
crazy.
know, it's crazy. We need to make it happen. It's about time. Because I
Yeah,
feel like our paths are crossing more and more often. So I think one of these days it's gonna happen.
indeed, indeed. No, I feel like a proud mentor just watching your journey as you go from
Oh, thank you
conference to
so much.
conference. But yeah, no, in your own words, maybe introduce yourself and then tell us where you are in your journey right now and what is next.
All right, well, thank you so much. I'm Rutendo Kahari. I'm from Zimbabwe. I moved to the US 3 years ago for college. So I currently go to the College of Saint Scholastica in Duluth, Minnesota, where I am studying biochemistry on a pre-medical track. I'm interested in both like the medical degree and the research side of things, which has given me a lot of opportunities to deep dive into different types of research. I'd say my first ever research experience was in bacteriophages. And so these are like viruses that infect bacteria. So one of the things that I'm passionate about is trying to find ways we can use science to eradicate some of the prevalent diseases that span across the African continent. So things like tuberculosis, malaria, cholera, HIV. And so I was very intentional with the types of research experiences that I've been deep diving in. So I spent a year and a half in the phage lab, which gave me like the opportunity to present at different conferences, including one at Harvard, Africamps last year, and most recently at Stanford, where I actually got like some awards for one of like the top presenters. Thank you. Uh, oh, thank you. Yes. Yeah, and after that, this past spring semester, I wanted to challenge myself because I'm doing a biochemistry degree. So I delved into organic chemistry research because I really enjoyed organic chemistry. I'm one of those people. And so we were trying to synthesize what are known as like porphyrins, and these are like I'd say like four. It's like it's like a core that's found in things like hemoglobin and chlorophyll
Okay.
in plants. And so this is basically like the core where in blood, that's where the iron group would bind, and in plants, that's where like the magnesium group would bind, just to like facilitate photosynthesis or like the transportation of blood. And so we're trying to like synthesize that similar core and add our own metal. And there's some current research going on that you can actually create some like antibacterial nanoparticle. So again, it goes back to my world of like infectious diseases. So that's something that I was like trying to explore. It was very challenging. Yeah, it was a beautiful experience. So I did a little bit of that, and then fast forward into the summer, I had the opportunity to do research at the University of North Carolina, Chapel Hill. So this was like my first ever research experience off campus at an R1 institution, and I was like, dang, what have I been doing? Yeah, so no,
It's a different ball game at an R1 institution, and then a
I
university
know.
of that magnitude as well also shows you the real impact of research at that level, where resources are not the constraint anymore, which means now the answers that or the
Exactly.
questions you can ask, right, are not limited by resources. They're
Exactly.
really limited by the scope and your skill set and your imagination, honestly. Yeah.
Right. Yeah, yeah. Because I mean, it was just like so crazy to see like some of the samples that they were working with in that lab were from like African countries, and they're like, yeah, this is, someone from Malawi, or, and I'm like, dang, this is, I don't know, it's kind of like hit close to home to be like able to contribute to like research that can impact back home, which is like my main goal at the end of the day, to see how I can use my education to improve where I come from. So yeah, the 9 weeks at UNC Chapel Hill was insane. It was crazy. But I had an incredible PI who was fascinated by my curiosity, and he took it seriously, such that I ended up answering a research question that I had developed, because normally people get into a lab and you jump onto whatever is going on. And so I spent a couple of weeks reading some of the papers that had been published by the lab. I had a couple of questions, and the PI is like, well, nobody has ever asked these questions that you're asking. You might as well spend your summer trying to answer this. So yeah.
Nintendo, that's amazing. That's the stuff that lands you on a paper as an undergrad early on. Like that sounds really amazing.
Thank you, thank you.
Yeah,
Yeah.
do a shout outs to your PI, because this also is great. He identified a young mind that is energetic and also gave
I
leeway.
know.
Yeah, yeah,
Yes, yeah, yeah, yeah. So I guess I maybe a little bit about the research work that I
yeah.
was doing. So I was focusing obviously on like HIV research, and particularly on a process called splicing. And for those that are not familiar with splicing, I like to think of, how you have your DNA transcribed into mRNA and then translated into a protein. So I like to think of the mRNA as a rough cut of a movie, and there's this process called splicing, which basically edits the movie and removes the floppers, all the bad parts, and joins together the good parts to make like the final piece of the movie, which is the final mRNA that's needed to make a protein. And so HIV
That
uses
is a
that.
great analogy. That is, I don't think
Thank
I've
you.
ever heard of that analogy.
Thank you.
Is really
I had to sit down and think about how I could explain splicing to people that have never heard about it. I'm like, you know what? I think a movie editing
yeah.
could could work well. So like the virus uses a similar process to make the proteins, that it needs. And this is a highly regulated process in a way that the original mRNA or like the original footage of the movie, only 70% of it needs to remain unedited, and
Yeah.
30% is the one that's edited. And so my question was to see, can we push the virus to a limit to say that 70% that needs to be remain unedited, can we edit it such that the virus ends up making more proteins that it needs? And so it's like two experimental approaches. One of them was trying to like delete a segment within the genome and see if it was contributing to like the regulation of how the editing process is done. And the second bit was to see if there are any current drugs on the market that could induce, so the term is called over-splicing or over-editing within the virus. And either way, it would cost the viral's fitness and, essentially like kill it. And I think one of the things that drew me to this project, or like the question that I was trying to answer, is that there are at least 30 plus FDA approved antiretrovirals on the market right now.
Okay.
And none of them target this process called splicing. I mean, mainly because also like our human cells use it, but I'm like, is there a way where we could only tamper with the genome of the virus as much as it's already integrated into like the human genome, but only like target that? So that was something that I was trying to answer. And yeah, we did a bit of work using a lot of like molecular cloning techniques, and I really spent most of my time trying to do one of the approaches where I was testing a drug that's already on the market to see what it would do. So I was working with a known splicing inhibitor, and I did like a gene insertion where I added like a nanoluciferase so that it would give like a light signal every time splicing happens. And so we're trying to track the splicing progress with an increase in concentration of the drug across a certain time point. So obviously, as you increase the concentration of the drug, the light signal was going down, meaning that that splicing was being inhibited. So like in the real world, if we were to find a drug maybe like ibuprofen or like Tylenol and test it, and we see like a change in like the light signal, we'll be like, hey, to the pharmaceutical companies, look into Tylenol. It's probably doing something with HIV, and it's already approved. So then it would, I don't know, be something like really, really cool. So yeah, it was like a great 9 weeks, and I'm like, oh, I wish I could extend. I wish I could extend my time, but I had a great time. And
I love
did and I did presentations as well, an oral presentation as well as a poster presentation, and I actually got an award for being a top presenter for my poster presentation. So it was like a nice way to like wrap everything together. Yeah.
You are collecting these awards. You are not wasting time. Which, by the way, you won an award at Abercamps, right? Which we were just talking about. See, you've been collecting Stanford and now awards.
I mean, the Abercamps one, I didn't see it coming because that was like my first time going to one of like the biggest conferences in the country, and I was just like intimidated. I think I had like 4 judges come to my poster, and I'm like, I don't even know if they're hearing me. I'm not hearing myself. And so that was like so unexpected, but I think with like lots of practice and support, I've kind of gotten the hang of it.
And also, you are enthusiastic about the research, which I think is the crux of this all, is that you are inquisitive, right? You're curious about science, which is already a big asset when you come into the scientific communities, because curiosity will lead you through the challenges, the ups and downs of science. Right. Experiments don't always work out. Sometimes they fail.
They never do.
And as with any job, it's not always going to be super, exciting.
Right.
But the curiosity, staying sort of enthusiastic about answering questions, pulling threads, that's the trick to get you consistent to get through. And then people, when you start talking about your research, people can sense the enthusiasm. They can sense your curiosity. It's infectious, right? And that's part of what people want. Because a lot of people, even though they are in sciences, they're jaded. They start, talking about their research not in a light. Maybe they're just, bored of the time that they've been doing it, whatever. But
Mm-hmm.
you have managed to not fall into that pitfall. And what I really love about your journey so far is that you are getting to experiment with different types of questions, right? So scientific questions, there's so many in abundance, right? And the only way you really decide what you want to do for the rest of your life is really by experimenting and asking different questions so that you know what are the questions that you like. And then some questions require different skill sets, wet lab versus dry lab, a lot of data analysis versus a lot of, maybe less data analysis and more data generation.
Yes.
Take on that end. You're also experiencing research in different facilities, an R1 institution versus a small college. A peek of how the impact of your research could be received on a global international stage like Abercrombie, but also at like top universities at Stanford. You're also seeing that on multiple different levels, academia, and you're thinking of questions in the sort of like basic science sense of, but you're also thinking of questions in the translational science piece. You're thinking of how drugs now could be made, in the context of this, super difficult question, and making tools to enable that. This is so exciting, Rutendo, and
thank you.
I'm so proud of you, but I'm also just excited for your future because it seems like you're really getting great experiences, not only for your resume, which is obviously awesome, but for your own professional development and growth and deciding what you want to do next. Because I'm telling you, if you're able to decide what you want to do and figure that out early on, from the other side, I'm just telling you, it means basically you never have to work a day in your life because you're doing something you enjoy and you're found the thing that you enjoy lines up with things you're good at. That's where you want to be. You want to be right there.
I'm trying.
And you're gaining the skill set as you go right now. All these different tools that you're using, whether it is cloning or, the data analysis tools that you're using or protein design tools that you're learning, hopefully, through Simulator or other areas, you are learning quite a lot. And even just like the theory, even you had to basically study quite a lot of these different papers.
I know.
Specifically about HIV, but also about the tools in HIV, the drugs that have been associated with this luciferase system that you were using. You had to read more about that too.
Yeah. I would say definitely like the learning curve was quite steep. I had to rely a lot on my genetics class that I took fall 25. And that was probably one of the hardest classes that I've taken. So I remember seeing splicing and I just had like nightmares. I'm like, oh my God, this is genetics all over again. And I'm also like grateful for like spring I took biochem too. And they really it was more like a journal club where we actually had to read papers. We are breaking down a paper. How do you read a scientific paper? What questions is the author trying to ask? How are they answering? The whole shebang of reading a paper. And so then coming to UNC, I'm like, okay, you know what? I can read a paper and then I can also formulate questions that I'm like seeing gaps within like the paper that I'm reading. So I'm like super grateful for some of the classes that I've taken. Sometimes it doesn't make sense. Like, why are we reading, 3 papers in 1 week? And, doing like many presentations, but getting to talk about my project almost on a weekly basis. I felt that some of the things that I did at school really, really helped and made sure that I was, meeting a certain expectation.
Yeah, no, that's awesome. And so, now that you have garnered all of these experiences and you have built up your toolbox, obviously now the onus is for you to give back to the students who are following in your footsteps. I'm seeing a lot of my footsteps in yours, like I remember presenting at Abercrombie in 2010.
Whoa.
2011, maybe 2011. That was in St. Louis, Missouri.
Okay.
And I won the poster presentation in biochemistry. It was my first conference like that. It was amazing, and it completely changed my trajectory in science and stuff. And ever since then, I've literally just been talking about how Abercrombie has to be the conference that you go, particularly if you're a student from underrepresented minority background. Abercrombie is the one to go. I don't care if you're not a biomedical student. I don't care if you're in physics.
I saw people like having like math presentations. I feel like if you're in STEM, definitely whatever research you've done, everybody is welcome. And I appreciated like the diversity because I feel like most of the conferences that I've been to, it's mostly like within biology or within healthcare. And so it kind of shuts out other people that are not doing healthcare related stuff. But with Abricams, it's like everybody, whatever research that you're working on. Yeah.
Yeah, and it's wide range of training sets too. It's everything from community college, undergrad, grad students, postdocs, faculty are there recruiting. You have every school under the earth that is there. Like Yale is there, Harvard is there, Howard University is there, Claflin is there. Every university is there trying to recruit their students. Pitching their programs. Yeah. That's a way to get GRE waivers. If you have getting ready to go to grad school, get your GRE waiver. It's a good time to get FaceTime with potential faculty that you would rotate with.
Right.
So I've always talked about Abricams just because after that experience, I've gone back as a grad student. I've gone back as a recruiter for a company. I've gone back as
a judge.
As a judge, I went back as a judge.
Yeah, I remember.
Oh wait, were you? Well, so you went to Abricams when? Last year? Oh, I missed you last year because I didn't go last
year. Yes, but I think there was a point where you like mentioned that I don't know, maybe that was like 2023.
Yes, 2023. I went as an exhibitor and as a judge. I won the award.
Yes. I remember you mentioning it.
They worked me too hard. Let me tell you something. I think I had to judge like 19 different posters. I said, let me say something. I don't know if that is for me, okay? But exhibiting with Stimulator. We literally exhibited at Abricams, which is so cool. And so this year we're going back again. We have students are presenting their posters. Rutendo actually has some insights on previous meetings that we've had, that we have some data finally from all of this Stimulator.
Okay. Yes.
Which is very exciting. Some of the proteins that people have been making, whether it's writing lyrics in Debele, writing lyrics from rappers on Instagram, Nicki Minaj lyrics, all of these different things have now culminated into an actual research question, which is, does natural language infer any protein stability? And there's some answers there, okay? Based on not just one lab, but two independent labs, one in Boston and one in Switzerland, have done similar experiments and also have thermostability experience. And so I'm very excited about the collaboration coming up in the fall with Hampton University, who will also be looking at some of these proteins on a more microscopic level. And we have students across all these places who will be presenting at Abricams. We have Hampton students who will be presenting. Of course, Camara Ice, who's part of Stimulator, will be presenting. And we'll present at a hip-hop conference as well as at Abricams. So we're intersection of hip-hop biochemistry. Obviously, we would love, Rutendo, for you to come and present as well, full sponsored and everything, but I know your time is limited. I want you to take advantage of as many opportunities as you want. As a student, you're welcome to come through, present. Of course, you'll be an author on the paper that we're writing of all of this, as well as any of the future patents that will be associated with the molecules, of course, that you contributed to. Invited.
I'm definitely like interested. I feel like any opportunity to like develop professionally, I'll take it. You don't have to like ask me twice. But I will definitely touch base. I think if registration is like still open, I would be interested in like registering, and I would just have to confirm the dates and everything as soon as I hit campus, which is in probably 10 days.
Okay. So I think the registration is open until September 11, and it would be good to apply for the travel grants as well. Even if you don't get it, Stimulator will sponsor it. It'll be good if you get it. Also, something you can list as an award, right? Which is great. Did you get a travel award last time?
No. So I think the issue with the travel award is for U.S. citizens. So as an international student, I don't qualify for it. Yes,
Oh,
yes, yes. So
I did.
I had to like source some institutional funds as well as like personal funds to like make it happen. So I was
Right.
like very happy when the trip was like
Yeah.
fruitful. I'm like, okay, it was worth investing in. Yeah.
Well, this year it's actually in Seattle, which is
I've never been.
hey, but that's where I got my PhD. This is the
I
lab
know.
of
Yes,
Baker.
yes, yes. Your Baker Lab.
Yes, yes. I'm very excited about it because I definitely want to see if I can visit, bring some students along, get to see a Nobel Prize winning lab. I haven't been also to the lab since the Nobel Prize. So that'll also be a trip for
You
me.
have
Which will be exciting.
to.
So yeah, I'm hoping everything works out for that, which would be really cool. And yeah, so we want to get as many students as possible. We have also students from the
Okay.
University of Benin in Nigeria who will be
Okay.
presenting virtually. In the
Ah,
past,
okay.
we have sponsored students who present virtually from Ghana and Rwanda and Zimbabwe. And so
Okay.
Lawrence and McGregor, who are the co-founders of Protein Design for Africa, we had a project on the side that was part of
Okay.
the adaptive competition where we did like a binder design project for an actual therapeutic molecule, and
Okay.
we actually have a binder there. We have a protein that binds, which is so cool and would
Hey.
have been ranked like the top the five molecules in the actual
Oh
competition had it
wow.
been selected. So it's super cool. We're even looking at structures and stuff like that. So they're going to
Wow.
present virtually, and then
Hmm.
we have Linda, who presented virtually in 2023 or 2024. I don't remember.
Okay.
She presented at ABCAMS virtually, and now she's actually a grad student in Texas. So she will
Oh
be coming
wow.
in person now at
Oh wow,
ABCAMS.
that is so cool. Like a full circle moment right there.
Cool moment. I'm telling you, Ivory Camps is such a community because also my alma mater, Claflin University, always is there every single year. And so every time I go, it's
Ah,
it's
nice.
a celebration. It's a link up. And then my other alma mater,
Hmm.
UW, Erin is the recruiter for UW for all programs, and she's always at Ivory Camps.
Yeah.
That's also
Ah,
like a whole thing. And then people over the years that I've just made at Ivory Camps, it's always great to meet. I like to connect, potential job opportunities, potential,
right.
postdocs, make sure things are connected. Novartis, my former company, is always there. And so it's always great to also connect people with that.
Okay. Yeah.
I hope we're able to make it work. But, our last few minutes before we log off, I really want to find out, Rutinder, how can Stimulate help you? What is the next steps? That you're getting ready for graduation, right? Are you about to be a senior?
Yes, so I'm entering my senior year. Plans changed a little bit. I thought I was gonna graduate in December, but now I'm extending. I'm graduating in the spring. But my plans are still pretty much the same, except I don't really have to worry about finding a job right now, which was one of my biggest things. But I'm going to be prepping for the MCAT because I'm going to be like applying to medical school, like on the MD PhD track. So that's like the biggest thing coming up right there. So I think if Stimulator can like step in either with MCAT prep resources or like the MCAT fees, that would be like super, super, super helpful. And I think just looking ahead post like graduating, because I still have to like think about that. I am considering going back to the lab that I was working at UNC
Okay.
for like their post-bac program during like my gap year because applying to medical school is like a year-long process. So I still have like a year and a half to kill even after graduating while I'm waiting for the medical school application process to be over. So I am hoping to like apply to the UNC postbac program, continue doing research. Ideally, I mean, after speaking to some of the people in the lab, ideally I would be continuing like the question that I started this summer. So I already have like an already existing project, and also I'll probably look at similar research programs like that because I think um, especially with like the MD PhD application, it's almost quite easy to provide evidence why you want to be a doctor versus why you need both the training. And so I've been trying to find ways to like really show that I think the work that I'm doing in the lab is going to influence how I'm going to treat patients or even provide treatment options for the patients that I'm, taking care of. And yeah, so that's what I'm looking forward to this semester. Is gonna be crazy, but I think I'll survive.
Will survive. If you survive, you will thrive. And let me just tell you, things of what you just said here. Number one, like graduating in December is overrated, okay? And it's actually good to graduate in the spring. I graduated in December and then I had to come back and walk in the spring.
Okay.
I hated it. And then because you graduate in December, you're always off center with the rest of your class. And so
Mm-hmm.
it's just not good. It's better to be in step with the rest of your class.
Okay. Yeah.
So yeah, and it's overrated. Don't worry. It's good to graduate in spring as you're doing. And you get more time as well to, line up your next steps. The whole point of graduating is to make sure it secures your next steps.
I know.
Don't rush to
know.
graduate if you don't have your next step secured. That's one.
Right.
Two, love the idea of a post-bac. I did a post-bac. I did my
I
post-bac.
know at Novartis, but I don't think they accept international students anymore because I was like, Dr. Mook did it. How can I? And
No,
I
they
don't
do.
think
They do. They
do.
definitely do. They definitely
They
do.
do, really?
Yeah, we need to get you into contact with some people, but they definitely do. I mean, I can double check. You are at UNC Chapel Hill, and the best person to talk to is right there, Christiane Hill, who I think is now the director of a neuroscience program there. We should definitely connect you. She also did the. Did she do? She might have done a summer scholars program, an internship, which actually. Now that you'll be graduating in the spring, you would actually qualify for the summer scholars internship. Oh, Retendo. Oh, I think it cut off. Oh no, the network. Oh no. Oh no. Retendo, can you hear me? Let's see. Maybe. Oh, let's see. She needs to. Oh, it's loading. There we go. It's loading.
Oh, okay.
There we go. Yes, we're back. Okay. No, but I was saying Christiane Hill actually is a director there at UNC Chapel Hill and one of the programs. We should definitely get you connected.
Oh, I think I know her. I think I know her.
Yeah, she did either she did a summer scholars internship at Novartis or she did the post-bac. Either way, now that you're graduating in the spring, you're actually qualified for the summer scholars program at Novartis. It's actually the internship, the 10-week internship. You actually qualify for that because it would be in the summer if you wanted to do
Okay.
But
Okay,
post-bac,
okay.
you still qualify. Let's get you connected. One thing I was going to say as well, one thing I didn't do that I wish I had done, I found the post-bac internship and I just jumped on that. I didn't even explore other options. Turns out there are many options for post-bac opportunities. And one that I would venture for you who, since you've already found a home lab that you're interested in, right? What you could do is apply for programs that would fund your time in that lab. So you could actually get the opportunity to have basically two paychecks, one from the lab and one from the program. There are these programs called post-bac programs. The whole idea is to get you into graduate school. And so you do GRE or MCAT.
Yeah, so those ones, they are for US citizens again. I did my research, Dr. Mook. So I think the ones that are open to international students are known as like Prime. So they are similar, but then the funding source can be given to like international students. So there are schools like I think UNC has it, University of Michigan, University of Washington in St. Louis, and also I mean like private institutions like Stanford, they have like their post-bac program, which I'm going to also definitely be like applying for because one of my mentors is currently like an ambassador for it. So I think anything that's like prep, it's like US citizens, and I've just been like, okay, let me focus on somewhere where the door is more open.
Well, it's good you're doing your research for sure. I remember this being the bane of my existence is that programs are available, but they're not available for international students. It sucks.
I know. You start with like 100 and then it just shrinks to like 5 options. And I'm like, okay, I hope for the best.
But I feel like now with AI and stuff, it should be much easier to prune that out. I think if you
definitely.
It must be. I hope you have like some sort of Excel sheet that you're navigating as you do this.
You know me.
That's good. Okay, and then the other part is when you talk about MD, PhD. I think with your time as you are applying for the MCAT and you are figuring out how you're going to source that. Definitely try to shadow somebody who has an MD PhD. I think that's a
Okay.
very useful thing to do right now, because
Okay.
you really want to answer that question, like, do you need both? Yes, it's a question in the applications for sure, and so you want to get a prep answer ahead of time, but also for you yourself, like you
Okay.
are basically about to commit to 2 life sentences,
know.
where most people struggle with just the 1 life sentence,
Yeah.
right? So before you commit to it, you really want to
Really
make sure
want
that
to.
it's necessary, one, for your next steps, right? What do you want to do with the MD PhD that cannot be achieved with an MD alone or with the PhD alone, right? Because if you just want to become a medical doctor, a physician, family physician, you don't need the PhD, right? If you want to become a researcher working in a research lab full time, you don't need the MD, right? And so you really want to find people who have the MD PhDs. And I know a few. We could definitely introduce you to a couple people who have gone through the programs, but also, shadow them if you have the opportunity to actually like have conversations, find out about their day-to-day lives. When they ended up applying for jobs, was the other degree actually useful for getting the actual job that they had?
Okay. That's a good perspective.
Maybe it wasn't. Yeah. And I think there's a light that's shined on MD PhD programs, because it's like, oh, this person is super smart. They are doing everything, which is very attractive, like to go for and go after. But it does come with its own challenges, and if you can avoid that, then why bother? Especially since PhD programs are fully funded, there is no expenses associated. In fact, you get a stipend. MD programs, you have to pay, and I think MD PhD programs are a hybrid. I think most of them are paid for, but then there's some that there's a component that you maybe have to pay, like residency or something.
Right.
So, but you know that you've already been looking into that. How Stimulator can help, for sure, it's the connections all associated with what we were talking about.
Yes, definitely. Yes.
So that but also you were mentioning your MCATs, is you're preparing for that and paying for that, and then study opportunities, whether it's GRE MCAT prep books. I don't know if Kaplan is still the one to go to. I did that one.
Yeah. I definitely have like the Kaplan books. So they're still like a go-to source even today.
Oh, they are? Okay.
Yes.
Worthwhile enrolling into a Kaplan course, because like structure is so good about study. When you're studying for something, you're having structure, having deadlines, having like a weekly thing to go to. So it's just so useful, especially if you're a busy person with all the other stuff. Just having.
I know. Yeah, I definitely considered that. I think like really like the biggest barrier was like the cost, because I think it costs like up to like 3,000. So I'm like,
yeah. So this is somewhere we can help. We can have conversations about this, particularly for sure. We can help with that. Right now, season 6 is ongoing. Okay, there is an opportunity every single day for the next. Well, it's no longer 30 days. I think it's now 24 days to win up to $100 a day just from answering questions in the videos, and then the person most points, Stimulator coins, at the very end of the season wins $1,000 grand prize. Which we do this every season, and so there's an opportunity to win $4,000 in this season alone. So that's one way.
Yeah.
Also, as you know, we have scholarships that we offer. You actually won one of our first scholarships.
Yes. I remember. It came at the right time. Yeah.
So we would be happy to also do book scholarships, as well as MCAT prep scholarships moving forward. Yeah, let's have more conversations about this coming up. I'm very excited for you. I think any way we can help you.
Thank you so much.
Awesome. You're going to be the scientist in this world that we need. And so if we can help you on your journey, we'll definitely do that. And it's also great for me to have a fellow Zimbabwean.
I know. Yes. Oh, thank you so much, Dr. Mook, for like pushing this. I know I missed like the last 2 streams. I'm like, oh my goodness, I need this to be at a time that works for both of us. So I'm like super, super grateful that I actually had this opportunity to come and share my story on your platform.
No, it's good. And it's a good problem to have when you are too busy. That's good. That means you have a lot of things to do. That's great.
Right. Yeah.
And yeah, we need to find a way to eventually meet. Oh my God, I can't believe we've never
I
met.
know, I know, I
It's
know.
some
It's
conference we're going
crazy.
to meet at some point. Yeah. But yeah, Rutendo, thank you so much for coming on to Stimulator. I appreciate you. And as
Oh, thank you
always,
so
you are
much.
welcome here. You're an alumni of the program, of course. You're welcome to any future programs. But
Yeah.
also, we're just so proud of your journey that you are trailblazing for other Zimbabweans. Now, if you had any advice for upcoming Zimbabweans or people who are looking at
Ooh.
Abercams or people who are thinking of your journey, what advice, final words would you give? Yeah.
I would
What's
say
the
be audacious. Like be
Mhm.
audacious. Don't be afraid to like shoot your shot. You never really know what the door is gonna open for you. I did research at a very small school that nobody really knows about, and every time I go to these big conferences, they're like, "Where is that?" And I'm so glad that I was brave enough because at the end of the day, they care about your science, they care about your curiosity, they care about your drive. Those are the things rather that will get you into the rooms that you want to be in. So believe in yourself, be audacious, don't be afraid to like knock on any door. I think the worst really that can happen is getting a no, but at least you tried. I always think, what if I get a yes? And you shot for, the biggest program and it's a yes. You're like set. So yeah, I'd say yeah, that's something that I would encourage like young people to think about as they pursue different opportunities. It doesn't even have to be STEM. I think this applies across the board. Yeah.
I agree. I agree. That is some amazing advice. Thank you so much, Utendo. And yeah, you are the ending of our birthday stream. This is a 37-year-old. Oh my gosh.
Oh, happy birthday!
You. Thank you. It's been a really great day, and what a better way to spend it. Of course, talking about science
I
opportunities,
know.
the
Yeah.
future of the world. So again, thank you for tuning in, and thank you for those who have been watching. Mahalia, shout out to you. I see you might have been in the back there. Thank you so much for your contributions. People in the chat, shout out to y'all. Thank you for people on Instagram. Everywhere, people who are watching this in the live. There are folks in the Instagram. I see Ruffin Neurolab. Geniuses, what's up? Shout out to you. Thank you for that. Lawrence, I see y'all. Takura, Aliyah, shout out to you. Turkish, I see you. Thank you for tuning in. Okay, you guys have been on for way too long. And so I won't see you later. I will see you
See you
later.
later.